This is lecture number 4, static electricity, and we're going to tell you what you have to do. And you've got the document that you can download and print, and it'll say, go on YouTube or the internet, find a physics static electricity experiment and do it. Explain how it works, take a video of it, send it to us, we'll grade it depending on how you did. Now you got to use all those terms that we had put on those whiteboards up here. Induction, conduction, positive charge, negative charge, insulators, conductors, and grounding. In this case, I'm going to do a demo with this thing. You don't have one of these at home. This is a static electric generator, and it creates static charge. Watch this. So if I fire this up, you can hear it already sparking, but if I go like that, you saw a spark. Watch. See that big old spark? Okay, so that little spark is being grounded through here. So your static electricity experiment is just like this machine. This is an insulator. It holds electrons. This is a conductor. It gives off electrons. This rubber band knocks the electrons out of the air. And off of some stuff in there, they get collected on this ball. This ball has too many electrons. It's negatively charged. When I do this, I ground it. I share it with the earth through this electrical cord. This is that little 3-prong plug that I was showing you earlier, or talking about earlier, and it's plugged into my wall, and those electrons will go right out the wall. Okay, so this is just an example of a conductor, insulator. I conductively charge this so it's negative, so the rubber band's probably positive, because that's what I'm knocking them off of. This is a grounding rod. Boom, shared it with the earth. You saw the shock. Okay, now what I'm going to do for my experiment, you could do this with a balloon. You don't need a Van de Graaff generator. And you can make dancing bunnies. There's just a whole bunch of them out there. But these are pieces of paper, 2 types, paper towel and just regular paper. Now the regular paper is a better conductor. It's than the paper towel is. So the paper is going to leave right away. The paper towel is going to kind of hang out. So when I turn this on, it's going to charge this, negative. Now the pieces of paper, I've got a great big one up here so you can see it, are going to go to the top of the paper and it's going to stand up because negatives repel. But it's not a good enough conductor where it will leave right away. So the charge has to build to a point where negatives actually leave the ball and then conductively charge the paper. Paper becomes negatively charged, boom, off it goes. So again, negatively charged it's a conductive charge. Inductively charges the paper, so the paper gets polarized because the negatives redistributed to the top, and so it's standing there. And then when it finally takes an electron, it becomes conductively charged negatively. Negative repels negative, boom, and off it goes. Now the paper's going to move right away. But you can see there's some other paper still there. And you can see it kind of standing up. There it is. And then I just grounded it. And it all came back down. You go try that with whatever it is. So Mrs. Coolidge and I are going to be on Zoom. You can email us, hey, can you look over my PowerPoint? You can do this on PowerPoint. You can just take your phone and video what you're doing and send it to us. We'll make some comments on it. If we don't like what we saw or we need you to add stuff, we'll help you. We'll make sure you got a decent one. If we find some good ones, we're going to put them on our website so that you guys can see some good ones. And then once we put them up there, you can't do those ones. You have to do your own. So it can be really simple though. Any questions? You're going to let us know.